This video is about how to write net ionic equations for things other than like precipitation reactions. So the first one that we have here is an acid-base one. So we have HCl plus NaOH. And so what basically happens is the H goes with the OH. So this is, and then the Na will go with the Cl. So basically, what ends up happening is when you take an acid, a strong base, you get a type of salt, not always table salt, but Na is +1, chloride is -1, so NaCl, and water. Okay, so then if you look up, excuse me, on the ion chart, you'll see that NaCl is AQ, and water is going to be a liquid. All right, that's important to get those. Now you'd want to balance the equation. This one's already balanced. All right, so you can go through and do this the long way, and you can write the total ionic equation, which would be H plus Cl minus. Those are both AQ. Okay, one thing about strong acids, remember they dissociate 100%, so you can break that down. Okay, plus Na +1 plus OH -1. Those are both AQ. Okay. Now this salt here, NaCl, is AQ, so it would break down into the ions that make it. They're both AQ. And water does not break apart because it's not AQ. It's a liquid, so keep it together. Okay, only break apart things that are AQ. Okay, cross off the spectator ions. And so if you look here, you can see that Na is a spectator here, and Cl is a spectator over here. And so basically what you have left is H plus, okay, plus OH minus, and then those are both AQ. Okay, gives H2O liquid. All right, so that's the net ionic equation. So when you get a strong acid and a strong base like this, a lot of times you get the H plus OH makes H2O. Okay, let's try this one down here. Okay, so let's finish this one. And so the K, all right, is +1. It's going to go with the sulfate, SO4 -2. So we're going to do the crisscross and get K2SO4. And then the H will go with the OH and make water. Okay, now what you'll want to do is you'll want to use your ion chart and look up K2SO4. And make sure that the K2SO4, figure out if it's a solid or AQ. And if you happen to look that up, you would see that K2SO4 is AQ. Now, once in a while, you have to be careful because some of those turn out to be a precipitate and make a solid, so always check that. And then water is a liquid. Okay, H2SO4 is a strong acid. And so strong acids dissociate 100%. So what we're going to have is H2SO4 really makes two H plus ions, AQ, plus one sulfate ion, -2, AQ. Oh, I forgot to balance the equation. I got to do that. Let me do that first. So we got to have a 2 there, and 2 is 4, and a 2 here. All right, there we go. All right. So, all right, plus 2 potassium ions, okay, plus 2 hydroxide ions. Those are all AQ. Okay, then what's going to happen is we're going to have, this is AQ here, so we're going to have 2 potassium ions, okay, plus a sulfate ion. They're AQ, that's AQ, okay, plus 2 H2O, liquid. Don't break the water, it's a liquid. Okay, cross off any spectators. So C2 potassium, spectator. Sulfate, spectator. Okay, what doesn't cross off? 2H plus AQ plus 2OH negative AQ makes 2H2O liquid. Okay, now we're almost there, except we have 2, 2, 2. So 2, 2, 2 can be reduced down to 1, 1, 1. Then you can put the states down here. AQ, AQ. Okay, that's a strong acid, strong base. The key is strong acids, strong bases dissociate 100%, so you have to break them into ions, cross off the spectators. Now, what we're going to do next is go to when we have a weak acid and a strong base. All right, so let's do this one first. Let's complete this one. So the magnesium will go with the F. Magnesium is +2. F is -1, so it's MgF2. And the H will go with the OH and make water. And that will be a liquid. Okay, now you'll look up the MgF2, and it's going to be AQ. All right. Now, anyway, balance this equation. So we have two F's, so let's put a 2 in front of here. And that gives us 2 H's and 2 H's, so let's put a 2 over here. That should balance the equation. All right. Now the key is weak acid. So when you see weak acid, do not break it apart into ions. Keep it together. So that's AQ. Plus MgOH2. Now we're saying that that's a strong base. However, I believe that MgOH2 is not very soluble in water. But anyway, so it's Mg2 plus AQ plus 2 hydroxide, -1 AQ. All right, that's going to give MgF2 is an ionic compound that dissolves in water, so break it into the ions that make it up. All right, and then the water does not break apart. Oops, H2O, liquid. Now, what you're going to do is look to see if there are any spectators. Anything that's AQ on both sides, the same thing. And if you notice, the magnesium is AQ here, it's AQ here. All right, so that's the only thing that we can break or cancel out as a spectator. So then we rewrite what's left over. 2HF AQ plus 2OH -1 AQ gives 2F -1 AQ plus 2H2O liquid. All right, now you notice that we have 2, 2, 2, 2 if everything should balance there. Okay, so basically you can just get rid of the 2's in front of everything. I'm not going to rewrite all this, but that's what you would do, is just reduce everything to 1, 1, 1, 1. Okay, let's try another one here. Or why don't you try it, pause the video, try it, and then see if you can duplicate what I do. All right, so basically the Na, which is +1, is going to go with the nitrite, which is NO2 -1. Okay, and then the H will go with the OH and make water. That will be a liquid. This will be AQ. All right, so then, anyway, what we'll do next is we'll write the total ionic equation. Okay, HNO2 is a weak acid, so keep it together. Do not break it apart. Weak acids stay together. NaOH, strong base, break it apart. +1, AQ, plus OH negative, AQ. Okay, NaNO2 is an ionic compound. That's AQ, so break it apart. And we have water, H2O, liquid. Do not break that apart. Okay, anything that's a spectator. Well, Na is a spectator. That looks like that's it. So you rewrite everything but the spectator ion. HNO2 plus OH negative gives NO2 minus 1 plus H2O, liquid. At the end, make sure your equation balances in terms of atoms and charge. Look how this side's a -1 and this side's a -1. Same thing happened up here at the top. The charges balance along with the number of atoms. Okay, weak acids. Do not break them apart into ions. Keep them together. Go back and look at strong acids. We broke those apart. Strong acids break apart because they ionize almost completely, whereas weak acids don't ionize fully, so you keep them together when writing a net ionic equation. Okay, one last type, single replacement reactions. Okay, so in this one here, the potassium is going to go with the nitrate. This is a single replacement, and so that's +1, -1, and all nitrates are AQ. And then the magnesium will go by itself and make a solid. All right, we need to balance this equation, so we'll put a 2 here and a 2 here. So balance your equation. Okay, now what will happen is we can cross off any spectator ions, or we could rewrite it the long way, so we could rewrite it. 2K solid, not an ion, so I don't put a charge, plus magnesium, 2 plus ion, AQ, plus 2 nitrate ions, -1, AQ. Arrow, 2 potassium ions, +1, it's important to have the charge on the AQ things, plus 2 nitrates, -1, AQ, plus magnesium solid, no charge, because it's a solid, see? Solid, no charge. Okay, cross off any spectators. Well, nitrate is always a spectator, almost. All right, so cross it off. All right, then you're going to rewrite what's left over. Okay, that was the only, you can't cross magnesium off because it's not AQ on both sides. It has to be AQ on both sides to be crossed off. So you go 2K solid plus magnesium 2 positive AQ gives 2 potassium +1 AQ plus magnesium solid. All right, now that's it. That's the final answer. But before you're done, make sure the atoms balance, 2Ks, 2Ks, 1 mg, 1 mg. But make sure the charge balances, +2 on this side, +2 on this side. So that does balance. A mistake that people make sometimes is say, hey, I can reduce this because if I cross this 2 off and I take this 2 away over here, it's still balanced. Well, correct, it is balanced in terms of atoms, but not charge. The only time you can reduce is when you can divide everything in the equation by the same number. Okay, so you have to leave these 2's there. Otherwise, the charge does not balance. Okay, let's try this next one. So basically what's going to happen is the aluminum, okay, which is +3, will go with the chloride, which is -1, and make AlCl3. And then the bromine, which will go by itself, but it's always Br2. Okay, so AlCl3 chloride is AQ, and Br2 is going to be a gas when it's by itself. Okay, so now we can rewrite this in a net ionic form. So Cl2 gas stays together. Okay, however, AlBr3 is an ionic compound, so it's going to break into ions, or it's already broken into ions. But notice how I put the 3 in front of the bromine there, because it's 3 bromide ions. Okay, that's going to make Al +3 AQ. Oh, you know what I forgot to do? I forgot to balance this equation. All right, that's a good thing lesson, because watch what happens at the end here. Okay, and so anyway, +3 chloride ions, -1, plus Br2 gas. Now, I forgot to balance the equation, and I can see already 3 chlorides and 2 chlorides, that's not going to work. So what I should have done at the beginning is I should have balanced the equation by putting a 2 here, all right, and by putting a 2 here, I need to put a 2 over here. Okay, now that gives me 6 bromides, so I'm going to need to put a 3 here and I'm going to need to put, that gives me, let's see here, what did I do here? That's a +3, so that gives me 6, so I'm going to need to put a 3 here. All right, so now if I go back and redo this the right way, I got 3 Cl2s, 2 Al, but 2 times 3, this should be a 6 there. And then this should be a 2 here, plus 2 times 3 is 6 chlorides here. And then that should be a 3 there. All right, let's see if we have any spectators. Okay, I forgot to write AQ here also. All right, so the only spectator I see is aluminum. Okay, you can't cross off bromine because it's AQ on one side and a gas on the other. So now let's see what happens here. So we write 3 Cl2 gas plus 6 bromide -1 AQ gives 6 chloride -1 AQ plus 3 Br2 gas. Okay, gases aren't getting any charges on them. Now, if you notice, everything could be divided by a factor of 3. And so if we divide everything in the equation by 3, we get Cl2 gas plus 6 divided by 3 is 2. So 2 Br -1 AQ. Arrow, 6 divided by 3 is 2 Cl -1 AQ. And 3 divided by 3 is 1 Br2 gas. Okay, now that didn't show up too good. That's supposed to be a 2 there. So do our atoms balance? 2 Cl, 2 Cl, 2 Br, 2 Br. Do our charges balance? 2 times a -1 is a -2. 2 times a -1 is -2. So if that's the case, it looks like you're done. All right, that's it on that. Now you should finish the rest of the problems on this worksheet on your own and check your work using the answer key that I posted online. That's it.